The topic is broad, but we'd like to narrow it down significantly. First, maybe from the like very top. The company we're actually working at this moment is their main product is a playout system for free ad-supported television. So the stuff you see on your smart TVs, anything from like Discovery, Fox Networks, Sinclair, you name it. The biggest brands, definitely in the US. I think they have like 50% of the market there. But what they didn't have until very recently, the time they acquired Telio, because we were a startup based in Finland, but most of the guys who built that startup were actually Polish. So we were developing two tools. One was a cloud-based video editing system for like a non-linear editing. So you can imagine Premiere, CapCut, stuff like this, but using only your browser. And the other tool was, or is, because it's still sold under a different brand, is called, the first one is Pro, the editor, and the second one is Studio. And this is actually a cloud production track. So yeah, a bit about us. So I'm the product manager of Studio, but that's not the only thing I do. I'm a broadcast engineer, a freelance broadcast engineer, so I work on broadcast tracks, on sports, on conferences, on cultural events, concerts and stuff. I also, not as much as I would wish, I do technical directing, so switching cameras is also the thing I do. Plus, I'm a streaming technology dinosaur. I think the first streaming I did was like 1997 or something like that. So basically, I have all the technologies somewhere imprinted in my brain. And we have been working for over 10 years together.
11.
Yeah, 11 at this point. Like doing mainly the same stuff. So Janek is our head video developer, but he also worked at the radio station as a journalist, plus he's done a lot of traveling, and he's a genius, obviously, as we are all, beside me. And Theo is our lead video backend developer, but also a practitioner, audio engineer, doing a lot of open source work. If you're familiar with a protocol called Dante, Theo did an open source like reverse engineering of the protocol, and it's free for anyone to use. But that's about us. And now let's cut to the chase. So first I'll talk about the whole idea, right? Because multimedia used to be something reserved for people that actually have a lot of money. So like if you'd like to work in television or in media, then first you need to buy yourself a lot of expensive equipment. And if you like gather all the stuff, either in the studio or somewhere else, the amount that's like minimal required, then you can actually create television. And nowadays it's not that expensive anymore, and you can do a lot of things in the cloud. And yeah, that's what we'll be talking about. So yeah, if you go into the truck and see how it's built inside, you usually have multiple compartments. Each and every compartment has a specific purpose. So there is a place for the broadcast engineers, for the people that do camera shading. They have a place to sit and work. And there's another one for the audio engineer, and other for the more creative people in the team. So technical directors, directors assistants, people doing replays or EVS as they are usually called in in the English-speaking world, and some graphics also. So now you have like a blown-up view of a truck, and going from left to right, you can once again like cut it to smaller pieces. So there's one for outputs, then for engineering control, vision mixing, recording and playback, audio, and access control. And in a physical OB1, you would have links that would come in high latency or low latency. So this is like you can compare it to RTMP or RISC, ZigZag, SRT for the higher latency links. For the lower latency links, you would consider using WebRTC or SIP maybe. If you work on a physical track on some venue, everything is just a feed of bytes or bits, and everything comes in at the very same time momentarily. Or of course, there's like synchronization mechanism, tree-level sync, and stuff like blackburst. Some of you might know those words. But here in the cloud, we need to have something to rely upon, like timestamps, time codes to sync everything up, so that at the very same time, all cameras show the very same frame from the very same moment. Since it's all divided into multiple pieces, our application, so Studio, is also divided to smaller chunks, and you have like applications, web applications, or just URLs you would use to control some parts of the backend. So you have like signal routing, stream monitoring, intercoms, vector scope, or waveform monitors for controlling the picture quality. You can do switching. You can have a multi-viewer, right? So like a mosaic of pictures. You can play out things, you can play out graphics, like things meaning clips, and you can insert SCSI markers, the ones working with CDNs that do ad replacement might know a bit about SCSI markers. Then there's audio, SIP, etc. And there's also somebody guarding the keys, right? So the user management. So if you think of it from a gaming perspective, or actually if you look at the pictures from like a computer perspective or a developer perspective, everything is a texture. If you decode something, it's like a plane of bits or multiple planes, and you need to move the data around. And you need to move it quick, because at 60 FPS you have 16 milliseconds to actually do your work, and then flash the buffers and next frames comes. So if you have like multiple steps, compositing, doing animations, there's not much you can do in this time, or you can do a lot as far as you have a fast system. So light speed is too slow, and like CPU is light speed, and GPU is ludicrous speed here, because like the PCI bandwidth available on physical machines is limited. On AWS EC2 instances is limited even more. So we need to use GPUs. That's why everything is a texture. And now comes the Dockerization part, finally. So what we've been building from 2018, I think, was a system that was built from ground up and like multiple steps, gathering dusts, and that might look like this system, which works. And if you have engineers that work 10 years for like building this product, it's fine. But when new people come, like it's really hard to get people up to speed, right? So ideally, you would want something that looks like a picture from Reddit cable porn channel. And so comparing those two images to real life, like the golden image, AWS built from Ubuntu, systemd, custom software, JNUS, digital glue, everything can be split into pieces that serve a specific purpose, and then have some control over it. Deployment is way easier if you just need to replace components that are relatively small. So now passing along to Janek, who will talk about the architecture.
Yeah, so we'll try to dive into the software side of things, and maybe starting with this wall of screen. Yeah, so these people like Mateusz, they usually operate with they can perceive like 20 screens at the same time and have, let's say, 2-frame latency, spot the 2-frame latency. So it is kind of a challenge having stuff in the cloud being viewed over WebRTC. If you are lucky with WebRTC, we get, I don't know, 50 milliseconds round trip time. So we have 0 milliseconds for all the operations we want to do here. So for example, if you want to do output from something which is on the cloud, on EC2 instance in the GPU, so it can be an OpenGL texture, it can be some VA surface, or in future probably like Vulkan-based mixers, VK surfaces. So we need to do it fast, and that was our main concern. We were a bit reluctant to dockerizing, adding any other layers, just not to lose any hardware acceleration there or introduce latency or glitches and so on. But yeah, Teodor proved us all wrong, and he dockerized all our stuff. So this is basically the output here, which is like a GStreamer pipeline with the VA GStreamer encoders. And everything goes 0 copy through the GPU and then to Janus, which we all use here probably. And actually in this demo we will be showing the software mentioned Docker Hub Janus, which works good for us. So every screen on this picture becomes a WebRTC stream in Janus, so we can have multiple multiviewers, some production view, replays, playouts, and we need to have enough encoding power and not a lot of latency just to have it for the operator of this whole broadcasting track in the cloud, let's say. Yeah. So this is, on the other hand, the input side. You have a lot of cameras on the stadium pushing some SRT feeds over public internet. And here we use our homegrown stuff. So we can, thanks to Amagi, show something which is open source. Here we can scan it and go to GitHub. And this is like the whole framework based on FFmpeg created by this guy here. That is basically a GStreamer-like wrapper around FFmpeg nodes. We use it for the ingests, and we add custom elements into the pipeline. So what you are getting on top of all that FFmpeg can do and libav can do is some async queues and nice APIs to have your own nodes. So like here we have a custom node just to grab the surfaces from the decoder, those GPU ones, VA surfaces, and then put them, for example, to OBS, like directly inject them to the textures of the video mixer or any other OpenGL video mixer you want to do it. And as I believe it is like the fastest and less latent way to do this you can possibly do. Here a bit of like the graph of AV Plumber, how it works with the hardware acceleration, and there's like demaxer and the audio and video path. The audio goes exactly like with one leg to the jack subsystem, which we'll talk about a bit. So, and the video goes, let's say, with the other pipe, and that's basically what you need to code in terms of like JSON text file just to get it running. And you can get it running also in Docker on Mac, even in Windows, and of course Linux, and try it out for yourself. That's what we are using in our Docker Compose here in this demo. And yeah, the third part, which is pretty important, and it was a bit scary for us to Dockerize, was those Chromium-based stuff. So Chromium embedded framework. And what Chromium can do from like a year or so is to directly export the buffers to Wayland GBM, so graphics subsystem in Linux, and then you can import those buffers in your custom CF-based app. So basically, without copying anything via the CPU, have it with the smallest possible latency. And we were a bit afraid of Dockerizing that stuff, and we had some issues with that, but I think all those issues were plainly related to NVIDIA, not supporting the open standards. So you can run it on host, you can run it on Docker. If you have Linux and the NVIDIA GPU, it simply won't work. Yeah, because NVIDIA just have alternative way of implementing all those Wayland GBM APIs. They do it their way, and it doesn't work for all the others. And what Google does, they just implemented how it should be, probably. Yeah, so that's why it will work on the Intel-based EC2. And it will work also on AMD GPU, and we are using the AMD GPU here in this example. But Docker, from our knowledge, doesn't break anything. Here, it just works. And diving into the Docker Compose, yeah. So the main idea was to not have anything at the host. Yeah, in the past we had everything on the host, and it was like a big mess of stuff. So we said we will go like full Docker way if we have completely nothing on host. So we also Dockerize those system level stuff. Yeah, so we Dockerize Wayland, which is like a graphics stack for Linux, the successor of X11, Xorg. And we also Dockerize Pipewire, which is the most modern iteration, I think, of audio on Linux, which has some back support for jack, which we use for our homegrown audio mixer. So this is like one container and the other container, and they share a bit of stuff between them. And it happens to work just on Linux by sharing some socket files and some device files. Like for Pipewire, it is basically a single file you need to do, and for video, it is this direct rendering device that you need to share between all the containers using graphics. And for AMD GPU, it is like basically just one file. You need to have pretty modern kernel and the GPU driver and Mesa installed, and then it just works. The second device is only for machine learning, like some async scheduling for the GPU, so just for graphics, and for our use case, it's not really needed. So yeah, that's the whole list of services you need to have. We also have a dbus service, which doesn't serve any purpose like for our application, but it is needed on the system level, and we can also run it on as a Docker container just for Pipewire and Wayland to work properly. And then on top of it, we have the whole sandwich of our custom-based video mixer, audio mixer, input, outputs, and so on. Yeah, so a simplified idea is here, and those services are basically the ones that we need to have running to have this demo here, which is, let's say, a bit simplifies use case of what we do in actual production system. And Theo will just present it in a minute. A bit of a pros and cons, I believe. The biggest pro for us is that we are coming from a 30-person small engineering company into 1,000+ corporation, and they have Kubernetes, they have huge farms of servers. I think the biggest AWS clients in India, so it is like completely different level for us. I think there is only one company which has like bigger cloud, but they run it like on their own completely. Yeah, so it was like Tata Cloud or something. Yeah, so it was like a huge scale, and we can have some advantage out of it. Yeah, so we can like have like bring your own DevOps or bring your own cloud, some tools that would easily provide Studio to be used on other environment than our personal AWS. So basically, you can run it on any machine. Of course, if you run it on Mac OS, you will lose some of those hardware-accelerated stuff I was talking about because they are dependent on Linux kernel. And if you don't have Linux kernel, then you will lose them. But anyway, you can develop something, yeah, like front end, or just have some simple demo out of it. And between the relatively modern Linuxes like Ubuntu or Fedora, you can just move it easily and migrate. And I think all the cons are like, one technical one is like wasting a bit of disk space because of the base images. Like for example, the Janus is a base image with Ubuntu that we use. The other ones are Fedora, the other ones are Alpine. So a bit of the application there. Building can take longer, but there are workarounds, and debugging, you just need to get used to it. We were probably used to doing it the old way, but yeah, there are also like workarounds for that. So probably if we would like simplify it to one base image, also this disk space won't be a big issue. Yeah, so basically right now it's time for a demo to get it all running, and Teodor will be the master of ceremony here. So.
Okay, but how to dockerize apps that use GPU? And on AMD graphic cards, it's really easy, as Janek said. It's just devices and environment and shared volume in the Docker file. Wayland compositor needs to be privileged and unconfined, but it works out of the box. But when we wanted to have everything in Docker, even Pipewire and Wayland, it came with challenges. For example, dbus didn't even print help message, which together with strace and source code gave us a hint. This is main function, and this is the long comment, so this is the first real thing that it does. And this won't be executed because glibc is not defined because we are on Alpine Linux in this container. So below this if def, there is this. Do you see a bug here? No? Okay. It is protected from negative max FDS, but it isn't protected from very large max FDS. So it was running for a very long time in this loop. The fix was very easy.
Yeah, I think usually you set it to 65K nowadays. So
yeah, it took around 10 to 15 minutes for a dbus to start. We just went to eat something and then it was running, so it was a pretty weird build, but we didn't need to fork it or patch it, just have the U limit. Yeah.
The other problem was with Pipewire, because for some reason Pipewire thought that process ID of our app is 0, and it is not a valid PID in Unix systems, by the way. We suspect that's because Pipewire didn't see client's process, because in Docker process trees are in different containers. So it was waiting for a management process to set permission. It should be Flatpak, but we are not in Flatpak. The fix was very easy. We've changed this comparison to this, and 0 was also assumed to be not sandbox, so it started working. And fortunately on Fedora, rebuilding things is rather easy compared to, for example, Debian Ubuntu. With these challenges fixed, we wanted to make sure that WebRTC works. So we came up with this gstreamer pipeline. It is very similar to our normal output of our studio, but it has GL test SRC. And the video does not leave the GPU this way.
So the thing you see is run on an EC2 machine in Ireland, I think?
Yeah, everything, this is in cloud. Everything is starting. And it works. So the next step was to run some video mixer. This is VNC. This is our audio mixer. So let's have some music. But Janus is not connected yet, so there is no music.
Znakomity festiwal, przepiękni ludzie, bryza od morza, górskie szczyty i zapach sosny. Zapraszamy do wspólnej zabawy. Oczywiście, panie, proszę, panie, spotkajmy się i tak jest źle. Spotkajmy się, bo gorzej być nie może. Czyli wszystko na temat występu grupy Kuźka Brothers. Zapraszamy do wspólnej zabawy.
So this is our audio mixer. We can add test tones, enable, disable inputs. In our production, on production machines, we actually have audio mixer written from scratch called DRemix, which stands for dynamically reconfigurable mixer, because you can add and remove inputs and outputs, and it works without glitches.
Yeah, hopefully we'll be able to open source it one day.
At least a bit of it, but the
Watch
point
this
is,
space.
yeah, this mixer runs as a container, and Pipewire runs as a container here in this demo, and there are hopefully no underruns and overruns, because with real-time audio in Jack and Pipewire, you have exactly 48 kilohertz like per sample, and if you miss it, it must be real-time priority, and if you miss it, you have audible glitches. So we haven't experienced it so far in the Dockerized environment.
And WebGL also works, and it is all zero copy, the browser sources needed for broadcast graphics. Work with high performance, no PCI Express bandwidth wasted, and we can even play audio through WebRTC, play the piano through WebRTC with low latency. And finally, my 7-year-long music school, going to music school for 7 years, found some use.
Yeah.
Okay, so yeah, fortunately nothing broke through for our presentation.
It was all scripted, yeah.
It was all scripted. So yeah, please do get in touch with us. Myself and Janek are also on the video dev Slack group, which was the place we actually heard about the Kraków Video Tech Meetup. So I encourage you to join. It's Googleable. Yeah. So if you have any questions, now it's the time. I know we're almost on time. So yeah, go ahead if you have any questions.
Thank you very much. So same as the last time, we've got one question here.
Was it too technical, by the way? Because we were asked to do a technical presentation.
I'm here. Thanks for talk. I have just a simple question about the NixOS. Did you consider to use NixOS?
NixOS?
Yeah.
Not yet.
Okay.
But it might be a good idea for server deployments.
Yeah, for server deployments, for like permanent systems, it might be good. But in our case, it's like we build this. We run those. We call them producers, right? The systems that do video, audio mixing, playing out everything. They are like single-purpose virtual machines. So we fire them up and then wind them down. So it needs to happen fast. And in AWS, the fastest way to do it is actually have this golden image. So like not everything, if you're running in the cloud, is like spinning up fast or as fast as you'd like, or as you're used to on your physical machine. But yeah.
Yeah, I can elaborate just a bit more why Fedora. So we had Ubuntu LTS experience, and basically like everything went outdated, like totally like 3/4 maybe of the stack was compiled on top of it. And what is nice in Fedora, I think, is that all those people working on Wayland, working on Pipewire and GStreamer, they are like closely related to Fedora, so everything comes directly from GitHub to the packages to Fedora, and it's really fast, yeah, and we don't have to compile anything. If we want to change something, like in the Pipewire, this one character commit we had, it is very easy to patch it on top of the existing repo, and we don't need to have everything pulled from master GitHub untested. We just used Fedora stuff, and we apply patches on top of Fedora GStreamer and Fedora Pipewire, not totally on our own. Yeah.
Yeah. And fun fact about that NixOS, I think there's one company in Poland from Warsaw that actually deploys like a kind of hardware software encoders that are based on NixOS. So they just come and plug the PC into the network, and it just boots up and builds everything from scratch. So yeah, for some purposes it's fine.
But the Docker Compose has an advantage of allowing any developer to have test environment on their device.
Yeah.
Okay, thank you. We have many more questions, so I'm going to pass on the mic.
Yeah, thank you. My question is about live streaming. If I want to, for instance, use your platform and get like inputs from different inputs and doing live mix, just I want to get like a little bit like high level information, technically how it's done, and about the latency. Does it work like perfectly, or will be some latency? Yeah.
Yeah. So this AV Plumber thing that we showed earlier actually has a feature to read two flavors of timestamps from the incoming MPEG TS stream, or RTMP to some extent. Like there's a concept of sync groups. So there's like a mechanism of actually getting a trigger system that fires renderer and all the frames from multiple decoders are getting flashed from the buffer at the very same time. So we have a way of synchronizing this, unfortunately, but it's not that uncommon to have high latency links coming even into broadcast environments if you have things that need to go over public internet. So like 6 seconds of latency for those backpacks that you see people from like TVP or TVN or all the big companies, they used to have like 3 to 6 second latency, and we can fit in that buffer. However, it countervents using this for some scenarios like live town hall meetings where the people need to actually interact with each other and cut in, and this only works with WebRTC. So actually when we have clients that need it, we tell them, hey, use our guest system, which is WebRTC based, and their sync there is okay-ish. So it's not in perfect sync, but it's usable.
Yeah, I actually wanted to squeeze in 2 questions, if possible. First one is, have you looked at Pipewire used for video? I know that's a possibility, but I don't know if that's even in the realm of usability in your particular scenario. I'm kind of curious about your thoughts on that. And the other one is, have you looked at any sort of HPC, high-performance computing type systems for RDMA to spread these Docker images across multiple nodes instead of having one very big, expensive machine, to have small machines and just have them cooperate somehow? I'm specifically thinking about stuff like Amazon's DI and Tiger Team initiative announced by Radio Canada recently.
Regarding the second question, we have preliminary tests with raw video over IP. So,
but only in the cases where we can separate, I think, the inputs, it makes some sense. So we are thinking of putting a replay machine on one instance because it has totally different inputs, and the main composition on the other one. If they need to share the inputs, it's sort of counters the sense of using the GPUs. Yeah, if you like spread every input to a different node on a CPU, so it's like a bit different architecture, but definitely, yeah, putting replays or putting playouts into different.
Or
And
outputs.
We did testing with AWS recently, and we were able to send like 4K, I think, 60 between two
raw,
instances
yes.
raw. So
Without any
yeah.
like CDIs or just ENA, the usual type of adapters. About the Pipewire, no, we haven't tried it.
No, only for audio. I believe you can just capture the screen from Pipewire, but if we just capture the textures from the mixer and then encode them, I believe it is faster, but yeah, no video in Pipewire.
Yeah, I think
For us.
about the HPC, like there is no silver bullet, right? For some clients that need relatively cheap system that can do a lot of inputs, then GPU is the way. If you have clients that need redundancy, resiliency, then a more distributed system that doesn't really need to have GPUs is definitely like more reasonable, I would say, to use. So
yeah, we can do the redundancy of the whole thing, so just have two GPU based, but we cannot have this case where we have one input which is decoded once and then fed into different, let's say, composers or something like that, because the inputs are baked with, and the decoders are baked with the mixer, at least in what we did so far. Yeah.
All right, thank you guys very much.
thank you.
Thank you.
Thank you.